Okay, this is going to be our last presentation on the lecture. I'm sure that you will be missing the lecture and the quizzes after this point, but you don't have to wait too long because we'll start it again in the next January. So, this is like the continuation of the last lecture where we left with, remember, the machine cycles and calculating cycles, just looking at the code. We just check our column 7. And based on that decision mode, we know how to calculate the cycles. But now, we have a new things added, which is loop. I'm sure that you have been waiting so long for talking about loops. Loops is nothing but just, still the branching. The only difference between the regular branching and the loops is, because in case of loops, we branch backward, because we want to repeat some of the lines again and again. How many times we want? Based on that, we want to repeat some lines. So the idea is you are still branching to a level but backward so that you can repeat some lines. Now, again, loop means a series of instruction which is same in high level, low level, whatever level you are, whatever language you are using. But remember, in the high level language, you have several different types of loops. Like for an example, in C++, you have for loop, right? You have do while loop, you have while loop. These are the 3 major loops you have, right? But here, we don't have too many loops, but we have too many branches to enjoy. So, pretty much, we do the same thing using the branches. So, in high-level language, no matter how the loops are written, no matter it's a for loop, no matter it's a do while loop, no matter it's a while loop, we can just write the similar lines in here using the branches, because we have, as you have seen, we have a lot of branches, right? And also the branches are also classified as signed and unsigned. So we have too many things. So based on that, we can easily just write the similar lines using no matter what loops is in high level, because those while loop, for loop, and do while loops are quite acceptable to the community, because it's in C++, it's in Java, and pretty much in all the high-level language have pretty much the similar types of loops. But again, in low level, we just have branches. Now, I just wrote 3 lines here. I know that it's probably too less for you, but we just wrote 3 lines to see the first time how the loops might work. You see, there are 3 lines. The first line, we are just doing some, like we are clearing the accumulator A. Now, by clearing, it means you replace the accumulator A by all zeros. That light's clear because you cannot make it empty. You have to put something there, so you just clear it, meaning you replace it by 0. Second line, we decrement A. Third line, there is a branch. Now, I think if you can recall, or if you use your set of instructions, you see the BRA is an unconditional branch, right? Which never stops. I'm saying it will keep branching no matter what flags are set, no matter what flags are cleared. Because it's unconditional branch, it will always branch, right? BRA. Now, tell me where the branch will make. I'm saying if branch will make always, right? So if the branch make, where you are going back? In line 2, right? So every time the branch make, you are going back to line 2 from line 3. That means what? Which lines are part of the loop? Which line? You have 3 lines here, right? Now, out of these 3 lines, which are the part of the loop, meaning which lines belong to the loop? Only 2 and 2, not line 1, because line 1 will be running only for 1 time. And after that, you go to line 2, you go to line 3, and then you come back to line 2 and 3. So 2 and 3, 2 and 3, 2 and 3, those will be repeated. Now, my question is, how many times this loop will be running? This one. This loop will run forever. Infinite number of times. You might be wondering, there are plenty of loops like this. Now, what happens with these loops? These loops will never stop unless your computer gets crashed or you turn off your computer. You will never be able to stop it unless you make it stop by doing something else. Like say, close the window or whatever. But this loop will never stop. It will run forever. I'm saying again as an example. Okay, it runs forever. Now, let's look at some real example. I'm saying more realistic example. But remember, I'm just trying to show you that it happens. We again have 3 lines here, and just like this class, the name of the level is magic. Now, the question is how many times this loop will be running. Again, the loop means which lines belong to the loop. Just as a quick guess. 2 and 3, right? Because you see, in line 3 you have a branch, and if that branch make, you will go back to line 2. So pretty much line 2 and 3, those are the two lines which belong to the loop. If the loop makes, I'm saying if the loop occurs. But line 1 is out of the same, right? Because the line 1 will be running for one time, and then you go to line 2, go to line 3, and in line 3 you might branch, you might not. If you branch, then that will be the second iteration. Okay. Now let's see. So first of all, we really at this point want to see how many times this loop will be running. It might be, yeah, it might be. Let's check. I'm saying we want to make small step at a time. Let's say step 1. I'm saying iteration 1. Remember, iteration 1 will be always there. So look at this. I just mark the loop grid just to just to show you that, okay, line 2 and line 3 are the part of the loop. Okay, now what happens in the iteration 1? Okay, now let's start from the line 1. In the line 1, that is still out of the loop, but you are like setting the plot because you loaded something to the accumulator A, right? First line, which is out of the loop yet. In the line 2, you decremented that 5 by 1, right? Because you are decrementing the content of accumulator A. So, in the iteration 1, what happens? Accumulator A becomes 0,4, right? Because the first line accumulator A is 0,5, and the second line accumulator A is decreased by 1, that becomes 0,4, right? Which is still, so now when you are executing line 2, you are already in the loop. You are in the loop already, right? Because line 2 is part of the loop. Now, line 3, you have to determine or decide whether the branch will make or not, right? Now again, this is a conditional branch, so the branch will make or not is based on the test condition, and we got the test condition in the column 3, right? Set of instructions, which is a very simple one. The condition is z equals to 0. We know the condition, right? We know how to get the condition, right? So the only flag that matters to us at this point is z flag, nothing else, because the branch will make based on z flag. Now tell me at this point, what will be the z flag in the iteration 1? Is it 0 or 1? See, when you are in the line 3, you will be checking all the flags based on what happened in line 2, right? Because that was the last line when the flags are changed based on whatever happened. Okay, so in the line 2 you had a subtraction, right? And because of that subtraction, you got a difference, right, which is 0,4. But 0 flag is not set because the difference is not 0, right? 0,4 is not 0. 0 means what? All zeros, right? 0, 0, 0, 0, all the way to 0. I'm saying all the results. So it's not 0. So 0 flag is not set yet. 0 flag is cleared, right? That means what? 0 flag is 0. So tell me whether the branch will occur or not. Branch will occur, right? Because the condition is meeting, right? The condition is z equals to 0. Meaning, if the condition match, you will go back to line 2. So that means what? We are going back to line 2. So that will be your iteration 2. Let's see what happens in the iteration 2. First, okay, in the iteration 2, what happens? After line 2, your accumulator A again get decreased by 1. Remember, what was the accumulator A last time? 0,4, right? Now it becomes 0,3. Pretty simple. Now, 0 flag is set? Not yet. So we are going to iteration 3. I'm just trying to show you the bigger picture very closely. Now, in the sound. Now, this is our third iteration. In this iteration, accumulator A becomes 0,2. Again decreased by 1. Z flag is not set yet. We are going to the iteration 4. Accumulator A becomes 0,1, right? Z flag is not set yet. So we are going back to line 2 again. And this is going to be our 5th iteration. Now what happens in the 5th iteration? Accumulator A is 0, 0. Do you see the change? 0 flag is set now, right? Now what happens? since zero flag is set, condition is not met this time. That means we are not going back to line 2 again. We are done. Now the question was, how many times the loop ran? What is the iteration number? 5. So your simple answer is, the loop magic ran only for 5 times. See how simple it is, but remember, sometimes don't guess just by looking at the code, because it might be, some people might be guessing just by, oh, there is a 5, so it might be 5. It may be different based on the condition of the loops. It may be absolutely different things. You cannot even guess most of the cases. But sometimes you have to, because some of the loops may be running for 100 times, 200 times. Those cases, you just cannot, go like these 100 times. But at some point, you will be able to see, oh, yeah, so at some point, these flags will be changed. And that time, it will be by this, iteration. Okay, what is the question?
When you check on the flags or the condition, is it only the Z flag?
No. It's just based on the condition of that branch. You see, that branch was, I got the condition from the column 3. For that branch, the condition was Z equals to 0. That's why we just cared about Z. But other branch, I don't think you have to wait. So let's look at the example 2. Now, example 2, we have again another branch, pretty much similar thing. Now we have, again, as you can see here, if the branch occurs, in the loop occurs, the line 2 and line 3 will be the part of the loop, right? Line 1 is out of the scene, but line 1 has a lot of things to do, because that line is loading something into accumulator D, right? Okay, that means what? Accumulator A has FF, and accumulator B will have 0, 2. Okay, and in the line 2, you are decrementing D. So now let's look at more closely again. What happens in the first iteration? Accumulator B is getting subtracted by 1, right? That means what? Accumulator B has what? 0, 2. Once it gets subtracted, it becomes 0, 1. Now look at this now. Now it's different. Your branch is BGT, and the condition is what? I think we have a better condition right now, right? So if you don't see challenge now, you see better challenge now. Z within parentheses N exclusive or V. Okay. So now we have to really care about 3 flags every time. We don't need C, but we need to know Z, N, and V. Every time after the subtraction is done, we will check all of these flags, because we have to see whether the condition is making or not. Now, after this subtraction, because in the line 2 there is a subtraction, right? It was a subtraction like what? 0, 2 minus 1, 0, 1. After the subtraction, 0 flag is still 0, because the difference is not 0, right? N flag is 0 as well, because your difference is not a negative number, because it's just a 0, 1, which is a positive number, right? V flag is not set either, because V flag only set when? In case of subtraction, it only sets when both numbers are different, right? Both numbers are not different. Both numbers were positive, because the number you have in B was 0, 2, and number you subtracted is 1. Both numbers are positive, so nothing was negative there. So all the flags are 0. I'm saying all these 3 flags are 0. And also, if you plug all the 3 flags here, what happens? The condition met or not? Condition is what? This has to be 0, right? If you plug all these 0, then this will be 0, right? So that means condition is met. So you are going back to line 2. That means this is going to be your iteration 2. What happens in the iteration 2? Your accumulator B becomes 0 now, right? Because it was what? 0, 1. You subtracted again by 1. Now what happens? You see again, the N flag is still remains 0. V flag is 0, but Z flag becomes 1, because you did the subtraction and the difference becomes 0. So Z flag is set. Now if you use it here, you will see the condition will be 1. So that means the condition is not met, right? That means we are not going back to line 2, and this was the last iteration. Now what? How many times the loop ran? Only for 2 times. And that's it. That's how we are going to answer these questions, okay? But let's look a little bit, one more. I know that you probably cannot wait to do the quiz, but let's wait a little bit. And then again, let's load. We loaded something into D. Again, line 2 and 3, part of the loop. And in line 2, we are adding 3 every time. So what happens in iteration 2? Look at this. Line 1, D was FFFA, right? Line 2, you added 3. After you add 3, D becomes what? FFFD, right? And the branch is BHI. The condition is C and Z, C plus Z equals to 0. So that means we will only care about flag C and flag Z. Okay. Now nothing happened at this point. C and 0 both are zeros because the addition, the sum is 0 and there is no carry, right? So everything is okay so far. So the branch will make again, right? Because C plus Z will be 0 again because C and Z individually both of those are zeros. So we are going back to the second iteration. Now what happens in the second iteration? You again add 3. Now what happens is, it's a little bit interesting. What was the D last time? FFFD, right? That was the content of D. So FFFD plus 3. What happens? How much you get? If you use the calculator, it becomes this, 1 followed by 4 zeros. Now what happens? The 4 zeros become the content of D, right? And this one becomes the carry, right? So that means what? The 0 flag is set because your result is 0. Carry flag is also set because there is a carry. So both C and Z are set now. You see? I wrote C1, C equals to 1, Z equals to 1. That means what? Condition is no longer valid. So we are not going back to line 2. So this is the last one, last iteration. So we are in the second one. The loop ran only for 2 times. Remember, in some cases, you will see that loop will be running for plenty of time. But in those cases, you have to guess. I'm saying after 3 or 4 times, you will realize when the flags will be flipped. I'm saying some flag has to be changed, right? So that the condition is different. Otherwise, for an example, in this case, if you C or Z, both or one of these change, the condition will not meet, right? Even one condition will, even C flag or even Z flag is met, condition would have invalid, right? Would have been invalid. So these will cover your 3 quizzes, 18, 20, and 21. As you can see, there are a little skip there. After 18, 19 is missing, and also, so we have quizzes all the way to 22. Now, all these quizzes are pretty much the same quizzes, same things, but the only difference is in some quizzes, in addition to just calculating the loops like this, how many times the loop is running, we will also want to see the runtime. Remember, we just saw the runtime last class, how we calculate the runtime, but the difference is now we have the loop. Now, for an example, this was our first example, remember? And we found that this loop runs for 5 times, right? We know how to find it, right? We just did it in the example 1. But let's say if somebody tells us, instead of calculating the loops, now can you tell me what is the runtime of this code? If the microprocessor speed is 4 megahertz. Okay. The question is a little bit frustrating because the microprocessor is too slow here, but you'll see some faster ones as well. Now, we know that how many times the loop ran, right? 5 times. So that means what? We know the mode. We can find out the cycles from the column 7, right? But the only difference is line 2 is running for 5 times, right? Because this is the part of the loop, right? So we multiplied the cycle by 5. You see what I'm saying? And line 3 is also part of the loop. So that means line 3 also ran for 5 times. That's why we still have the same idea, but the difference is whatever line we had inside the loop, those will be multiplied by the time loop ran. That's the only change. But remember, if we count the number of time loop ran is wrong, no matter how hard we try, this will be wrong as well. So, what is the total cycle here? 27, right? Once we just add all the cycles, 27. Once we know the 27 cycles, the rest is simple. It's still the same formula we used last class, right? Formula for the runtime. Total machine cycles divided by processing speed. Now the total machine cycle is 27. Processing speed is 4 megahertz given in the question, right? Divided by 4. We got the answer in second because that's the runtime. And in the question, in all of the questions, we mentioned how to write the answer. We will say, okay, write the answer in nanosecond, or write the answer in picosecond, write the answer in microsecond, millisecond, gigasecond. So you will convert it there, so you don't have to care about the unit. I'm saying you don't have to write the unit in the answer. So for an example, we wrote the answer in microsecond in this case. I'm sure that we know all those, right? Starting from pico to all the way to tera. Pico is -12 and tera is 12, right? Okay, now again, this is just an example. So pretty much this is still the same thing, because you still have to calculate the loops. How many times the loop is running. And then you have to calculate the total cycles. These will pretty much cover the remaining the quizzes. Now all the way up to from whatever we are now where 17, right? So starting from 18 to all the way to 22 will be covered by this lecture. Pretty much, because we just did loops, calculating the cycles, and then calculating the runtime. This is all about all these quizzes, all the way to the end. Okay? I'm sure that after this lecture you'll be missing the lectures and quizzes, but as I said, we'll just take a month break, and then after that we'll again come back in January to start our lecture and quizzes again. Okay? Final exam, I think we have it here written for the last column, and also marked red, December 10, 8 p.m. The time is a little bit different in the final, because that's 8 to 10, because it's announced by the college. So state the college-wide is a different. It's 8 o'clock.
8
No, of course not. Yes, 8 p.m. And again, we extended the deadline for Lab 3 report. Now the due date is this Friday. So, and all you have to do is just upload it into Dropbox by midnight. And also there is no class this week. If you don't believe me, you are welcome to come and check. So, if that is true, then we'll be meeting again next Monday. And we'll have 2 more classes next week. And I would recommend try some of the quizzes, and we'll talk about Lab 4 also tonight. Okay? Because Lab 4 is also about loops. So probably this is a good time to talk about loops. Okay?